Going back to the incline, so I have a force of 40 newtons pulling the object up, and I want to find what kind of acceleration I'm going to have, knowing the mass, the acceleration due to gravity, and knowing the angle, which is 30 newtons, and knowing that the coefficient of kinetic friction is 0.3, meaning we have friction. We have friction, ladies and gentlemen, we have friction. That means that besides the force due to gravity, besides the normal force, besides the force that we apply, there's friction, and friction opposes motion. So it should be at this direction, and it's kinetic because I'm looking for the acceleration, so it's moving. So again, I will need to resolve the free body, the force due to gravity, make a new free body diagram where I will find the x and the y components. And of course, let's not forget that here we have one more force. We have kinetic friction. You should be able to show that all forces start from this, and you should be able to show them, separate them, so in the AP exams they see that both forces start from the point mass and that they are parallel to the y-axis. They coincide, but we don't want them to coincide. That's what they want. Right, so let's move on. So finding the force due to gravity from mass times g, and then find the x and the y components. Again, always on the inclines, the x component gets the sine, the y component gets the cosine of the angle, because the y component is, the y-axis is adjacent to the angle, so it gets a cosine. So it's easy to find this, and then we go back to the usual stuff, meaning the sum of forces on the x-axis. Well, we want to find the acceleration, so there should be this. Well, the sum of forces on the the y-axis should be 0. Again, what do we have? I have the force due to gravity on the y-axis. So what am I going to do? I will use the sum of forces on the y-axis to find the normal force. There are no other forces on the y-axis besides these two. So positive, negative, normal force minus the y component equals 0. That means that the normal force equals 43.3 newtons. Now, from the normal force, I can find friction. How? Well, I do know that kinetic friction will be the coefficient of kinetic friction times the normal force. So if I consider the kinetic friction, the coefficient to be 0.3, I need to multiply 0.3 with 43.3 newtons. That's a very nice number. It should be close to 13 newtons. Let's check. So it's 0.3 times 43.3 equals 12.99, so I'm good to go. 13. So now I will use the sum of forces on the x-axis to find the acceleration. So what do I have here? I have three forces. I have this to be positive, negative, negative, and they should create an acceleration positive. So what I have here is force minus the friction, the kinetic friction, minus the x component should be mass times acceleration. So the force in our case is, I said it's 40, 40 minus friction, which is found to be 13, minus the x component, which is 25, equals the mass, which is 5 times the acceleration. So this is 40 minus 38 equals 5a. So my acceleration will be 0.4 meters per second squared. So again, I used the method I showed you. I went here, I did this to find the acceleration on the x-axis. How did I know where to start from? Well, I was looking for something on the x-axis. I couldn't start from the x-axis. I had to start from the y-axis and go all the way to the x-axis. I hope that helps.